Number theory and mathematics. Number theory is a natural and fascinating branch of mathematics. In the beginning, mathematics was evolved to address various issues in number theory. In fact, it is number theory which introduced mathematics to the world. Since then, mathematics is being continuously evolved and it has brought almost all branches of study under its wings. The impact and advantage of mathematics is so inevitable that today hardly we could find any subject which does not use mathematics. Though mathematics was born out of number theory, due to its exponential growth and application in the modern world, number theory has become one of the branch of mathematics. German mathematician Carl Friedrich Gauss quoted that mathematics is the queen of sciences and number theory is the queen of mathematics. Thus, it becomes natural for everyone to be curious about the journey of number theory. As every one of us had about, it started with counting of items, which led to the natural numbers. Then came the necessity of negative integers and zero. Zero is brought into the number system by our Indian mathematician Aryabhatta. Later on, rational numbers, irrational numbers, real numbers, complex numbers, quaternions and octanions were introduced into the number system. Even though so many categories of numbers are available, number theory basically refers to the properties and relations of the set of natural numbers. In mathematics, a conjecture is a conclusion or a proposition which is suspected to be true due to preliminary supporting evidence at which for no proof or disproof has yet been found. There are numerous familiar conjectures in mathematics. Interestingly, in number theory, we could find many fascinating conjectures. In search of justification or disproof of these conjectures, many branches in mathematics were created. In 1621, the famous conjecture Four-square theorem was conjectured by Gaspard Bachet. It states that every natural number can be written as sum of four squares. The theorem was proved by Joseph Louis Lagrange in 1770. He had justified that g of 2 equal to 4. Later, Hurwitz proved the theorem using quaternions. Four-square theorem is the starting point of Waring's problem. Edward Waring proposed Waring's problem, which is the generalization of four-square theorem in 1770. The proof of Waring's problem was given by Hilbert in 1909. The result is known as Hilbert-Waring theorem. There are many deductions of Waring's problem. Indian mathematician Balasubramanian proved one of the deductions in 1986, which states that every positive integer can be written as a sum of 19 fourth powers. Fermat's last theorem was first conjectured by Pierre de Fermat in 1637 in the margin of a copy of Arithmetica, where he claimed that he had a proof that was too large to fit in the margin. The first successful proof was released in 1994 by Andrew Wiles and formally published in 1995 after 358 years of effort by mathematicians. The unsolved problem stimulated the development of algebraic number theory in the 19th century and the proof of the modularity theorem in the 20th century. It is one among the most notable theorems in the history of mathematics, and prior to its proof, it was in the Guinness Book of World Records for most difficult mathematical problems. On 7 June 1742, the German mathematician Christian Goldbach wrote a letter to Leonhard Euler in which he proposed the Goldbach conjecture. Every even integer greater than 2 can be written as a sum of two odd primes. Though the conjecture seems to be simple, the proof is not. This is still an open problem. Twin prime conjecture is a particular case of de Polignac's conjecture. The conjecture was proposed by Alphonse de Polignac in 1849. A twin prime is a prime number that is either 2 less or 2 more than another prime number. For example, 11 and 13, 41, 43. The proposed conjecture is that there exist infinitely many twin primes. Though Hardy, Littlewood, Zhang have made substantial progress, the problem still remains open. The Collatz conjecture is a conjecture in mathematics that concerns a sequence. Start with any positive integer n, the term of the sequence is obtained from the previous term in a specific way. If the previous term is even, the next term is half of the previous term. If the previous term is odd, the next term is 3 times the previous term plus 1. The conjecture is that no matter what value of n we start with, the sequence will always reach 1. This conjecture was proposed in 1937, still it remains as a conjecture. The German mathematician Riemann observed that the frequency of prime numbers is very closely related to the behavior of Riemann zeta function. In this connection, he proposed the Riemann hypothesis. This is one of the 7 millennium problems established by Clay Mathematical Institute. Each of the 7 problems carries a prize money of worth $1 million. Except that of Poincare conjecture, the remaining 6 problems are yet to be solved. The Poincare conjecture was proved by Gregory Perelman in 2003. Surprisingly, he did not accept the prize money. This presentation on number theory and mathematics will be incomplete if I don't tell about the man who knew infinity. Yes, the great mathematician Srinivasa Ramanujan had contributed a lot to number theory. Starting with magic squares, he moved on to the theory of partitions, congruences, and highly composite numbers, provided several formulae for pi, and worked on Diophantine equations. Ramanujan proposed a conjecture that the particular Diophantine equation has only 5 solutions, and no other integral solution is possible. Nagel proved Ramanujan's conjecture in 1948. Though many of the familiar conjectures we discussed are remaining as conjectures, lot of results in number theory were proved using new branches of mathematics. Thus, from the history, it is found that each of number theory and mathematics contributed to the growth and development of other. Number theory, the mother, nurtured the baby called mathematics, and as the time progressed, mathematics has grown from strength to strength and had taken care of almost all the issues that prevailed in number theory, like numerals, love number, enjoy mathematics, and excel in life. Thank you.